What we did so far today is we went over the quiz, we passed it out to you guys, you talked about it amongst yourselves. How many people have 100 so far on the quiz? Just from I think 3, 4, 6, 8, 10, 12, 13, okay. Hey, shh, folks. There are 24 kids in the class and 13, and one absent today. 13 have hundreds. And Kaylee might have gotten 100 yesterday, I don't remember. Yeah, so 14 people. Listen, this is very predictable. It's not like, it's very methodical, it's very mechanical. If you can do one, you can do the rest. We're not throwing any curveballs. I'm not putting it 2n squared. I'm not putting in fractions. So you really should be able to get this right. And if you're one of the people who has not yet gotten the 100 on the quiz, I strongly recommend that you put some concentration and some dedication to that exact idea. And I think that you'll see that you get there, okay? Yes?
I like your tie.
Thank you so much. I did too. I thought a lot about it this morning in terms of what would go well with the outfit.
And then like the shirt coordinates with the jacket.
Yes,
the
does it?
tie coordinates with the pants.
Yes.
And it all just kind of like floats.
And there's a hint of blue in here that matches exactly the blue on the shirt. I nailed it, didn't I?
You did. But you got the hair.
Yeah, can you do any better than this? Can you?
I love your hair.
Thank you so much. It's very important to me. When you are as ungood looking as I am, it's really important that the clothes set the tone.
And if you ever just need to like fix anything, just come out. I got you.
I know. Well, we do our little, check out the look thing going on there. All right, now, Spencer.
Yeah.
If you would bigly get the lights, please.
Bigly?
Bigly.
What's bigly?
I have no clue, but that's what they say Trump says, and I always thought it was big league.
I don't hear bigly. I've never heard of it bigly.
It is. It's B-I-G-L-Y. It's in all the newspapers. They say it all the time.
That's weird.
Exactly.
It's a weird thing to say.
Okay. Hey, hello. Hi, Mr. Linquist here, trying to run class, a little thing like that. Quiet.
Emma.
Oh, AJ, that cracks me up. He was just talking to Janelle like crazy. I go, Emma. All right, now, let's take a look at the answers and see how you did. Emma.
Have you seen the video? And on the top it says like Trump, and then like corner mark it says the Mexicans will pay for the wall, and then it has like some video of the guy saying,
Anybody have any clue what lipstick is?
Have you ever seen the bad lip reading of the inauguration?
No. Can we get to this, please? All right. Okay.
All right, Trump, let's get over it.
Hey, right here, guys. Thank you. How many people are 100% set on the quadratic formula?
What?
I memorized it yesterday.
No.
There's a song. I know it's like X equals B squared.
Negative b. It's negative b times plus, no, negative b plus or minus the square root of b squared minus
Spencer.
ac over 2a.
Spencer.
Yeah, that.
Yeah. Listen, guys, I appreciate that you memorize it. That's a good thing, but I'm more worried about how to use it. So why don't we kind of bring it in here, right? Focus on this. Take a look at your answers, see how you're doing. Yes, Spencer?
My sister took, I think it was algebra, I'm not sure. She took one class where she had to know the quadratic, and she taught me a way to memorize it, but I forgot how to memorize it.
Okay, this is all good. Let's do this.
Okay. There's a song, we should listen to the song.
Spencer, come on, man. Any issues on the first 3 here? Okay. Okay, numbers, for the last 2 here, I only did one of each. I just ran out of time. All right. You notice that I rejected it over here. Why did I reject 2w plus 15? AJ? Yeah, when you get the root out of it, you're going to get a negative 7.5, which is a negative length, and I can't have that, so I didn't even bother figuring that one out. It's very important that you show that you reject it if you do that. Okay? And letter A is a really good example of what it is that we've had on the quiz, right? some of the things that I see kids doing wrong here on a question like number 10. Look, it's half and square. If you half the -8, what do you get? Guys, half the -8 here in the middle term, what do you get? -4. Kristen, you with me here? When you square that -4, what do you get, everybody? 16. I love to see the step where kids write a little plus 16 up here and plus 16 over here. And then on the other side, -8 plus 16 is 8. Then you square root both sides. The kids who are not getting 100 yet are making a mistake somewhere in here. This is where the fault lies. Now, I will be at the library tonight, and I will be at Extra Help tomorrow morning, okay? So I would recommend that if you, by the end of today, if you're not nailing this completing the square stuff, or possibly the quadratic formula, that you come in and we work a little one-on-one with it, okay? All right, yes?
Could you move the 4, since it's plus or minus? Or is the plus or minus not commutable?
Oh, you want to put the +4 over here?
Yeah.
Yeah, a lot of kids are doing that.
Okay.
Yeah, you get full credit if you do it. It's kind of traditional to put the 4 in front here because, as you're about to see, with the quadratic formula, that's where it would end up. See, here's the quadratic formula question from last night's homework right here. And see how we have this with the number, then the radical? So it's kind of expected in that form. Now, this particular quadratic formula problem, like the one we did yesterday in class, arrived at a whole number answer, namely 1 and -10. Traditionally, nobody uses the quadratic formula when it's factorable. And if you use the quadratic formula and at the end you get whole number, rational number answers, like 1 and -10, or fractions, that means it must have been factorable. And the whole point behind the quadratic formula is to work on ones that are not factorable, okay? So, today is day 9, I believe. And let's do exactly that, okay? As far as the completing the square goes, I want to go through this one more time just because I was still not, we're not sharp enough on these quizzes. We should be getting them right. I was hoping to just tell you the answer and then move on past this, but I just don't think we're ready yet. All right, solve for x by completing the square. Yes, Anthony?
What you have to do is that you have to turn 10x, no, sorry, what I meant was x squared minus 10x into x minus 5 squared.
Okay, pause there, let me catch up. Okay? All right, so we see, we want to do the half and square. Anthony realizes that I have to half it, so he makes it x minus 5 squared equals 4. Anthony, is that a true statement right now?
No, because what you have to do next is that you have to add the square of 5 squared, which is 25. And then
Right.
you get x minus 5 equals 29.
That's right. Now, just to be a little more clear, and you came up with all of the right numbers here, but you're squaring -5, not +5. Right? You're squaring this whole number here. So it's not just 5 squared, it's -5 squared. Just, it doesn't make a difference because it comes out the same either way. Perfect, very good. Anthony's right, we square root both sides. X minus 5 equals, step ahead of myself there, plus or minus the square root of 29. And then I'm going to add 5 to both sides, and I'm going to get x equals 5 plus or minus the square root of 29. And honestly, I'm very, very serious. We should have 100% of the kids in the class getting 100. We do a lot of questions during the course of the year that are very difficult because they're word problems and you have to see into them and you have to figure out what's the relationship they're looking for, and the state intentionally tries to make the most difficult type that they can come up with. Really ridiculously hard stuff. Rarely do we get questions that are very predictable, very methodical, they're all done the same way. Completing the square, as long as I don't do 1 or 2 variations that I don't expect to do, is very much that way. So, I think that this should be something that we're all perfect at. And here's another thing that should be perfect at, the quadratic formula. Now, you shouldn't be perfect at it yet, because we're only starting our study of it. But by the end of today, into tomorrow and the next day, we should then be perfect at it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I just want to come over here to the x squared minus 10x equals 4. This is not in the correct form for using the quadratic formula. With the quadratic formula, like factoring, you want to get it all on one side. Minus 4, x squared, minus 10x minus 4 equals 0. The a is always in front of x squared, the b is always in front of x, and the c is always at the end. Now we just plug them into the formula. X equals. What is the value of b? Everybody? Negative 10. So what's the negative of negative 10? 10. Plus or minus the square root of. b is negative 10, so I got to do negative 10 squared. Notice how I put that in parentheses. It is so important to put that in parentheses. If you do not, your calculator will tell you negative 100 instead of positive 100. Minus 4 times a is 1 and c is negative 4. And again, I put that in parentheses also. Now, and then a is 1, and I'm just going to do 2 times 1 is 2. Can everybody get their calculator out? And I want to show you how you can use your calculator in one giant fell swoop to figure out what goes under the radical. You could actually even do the radical, but I don't want to with the quadratic formula because I don't want decimals. I want to leave it in the radicals. But let's do this. Ready? Parenthesis negative 10 parenthesis squared minus 4 times 1 times negative 4. And I like to see you put the negative in a parenthesis just as a matter of habit. I don't think in this case it'll matter, but there are times when it does. And then equals, or enter. And what does it tell you?
Wait, how does it go?
Radical 116.
Parenthesis negative 10 squared minus 4 times 1 times negative 4. So x is going to equal 10 plus or minus the square root of, you said 116?
Yeah.
All over 2. Now, here's the little hitch that you're not going to know yet, but you will learn. The square root of 116 is reducible. It's square root of 4, square root of 29, and the square root of 4 is 2. Now, don't worry about that step. Do not even think about it. In a few days, we'll cover how to simplify a radical, and I'll reteach it then. Bottom line is, 2 goes into 10 and 2, and I get 5 plus or minus the square root of 29.
4 times 29.
And you will notice, whoop, up here, that the answer is the same either way. Okay? Yes?
Where'd you get the 10 from where the negative b?
Because the b is always whatever's in front of the x, and the negative 10 is in front of the x. Okay, the c is always the number at the end. The a is always in front of x squared.
Yeah, but where's the 4 come from? I'm confused.
Oh, that's part of the formula. Negative 4 ac.
Yeah.
So negative 4 times 1 times negative 4. And that's negative 4 times 1 times negative 4. And the negative 10 squared is the b squared. All I did was plug them in exactly where they go into the formula. Okay? Danielle?
Is that 116 you wrote?
Yes.
How do you, I don't understand.
Don't worry how to, don't even begin to worry about it. I won't ask you to do it for a couple more days until I show you how to do that. I just wanted you to see that the answers were the same, so I did that step. Okay, yes?
So what would the answer be in terms that we know?
5 plus or minus radical 29 would be the total answer. But if I was like doing it now and you wrote 10 plus or minus square root of 116 over 2, I'd be fine.
Oh, I did like.
It's just not reduced. And in a couple of days, we'll teach you more about how to reduce. Yes?
So you just get rid of the x, that's
You ignore the x to find the values. A, b, and c are coefficients in front of the variables. All right? Yes?
I don't know if you said this before, but why are you using a positive 10 in the, for the value? instead
Oh,
of-
because it's the negative of b.
Oh,
b is negative 10, so what's the negative of negative 10?
10.
10.
Okay.
All right, good question. Anything else? All right, so really, whether you're doing completing the square or whether you're doing quadratic formula, it's very mechanical. It's very methodical. It's really not a big thinking thing. Toby Keith used to have this song years ago called "Ain't No Thinking Thing," right? Brain, left brain. And it's the truth. You just work your way through this. So if you struggle with word problems, you have my sympathy, I understand. I struggle with word problems. If you struggle with certain other things in mathematics that are hard to see into, yes, it's really, really hard. This is not one of those things. It looks complicated. It is not difficult. Okay. So, let's do, I don't want to do the first one because the first one here comes out to be factorable. This one's factorable. However, this one is not. So let's do the third one. Quadratic formula on the third one. Go ahead. Okay. Did everybody get -1 plus or minus the square root of 13 over 2?
Yeah.
Good. Very good. What did you get, Sydney?
I didn't know how to do the second part of it.
This part?
Well, like, I don't know how to say it.
Well, look. The formula says the square root of b squared minus 4ac. So b is 1, so I do 1 squared, minus the 4 always stays the same, then a is 1, and c is -3. So you can literally type it in your calculator. 1 squared minus 4 times 1 times -3, it'll tell you 13. And then don't forget about the square root symbol. So it's -1 plus or minus the square root of 13 over 2. This time, I can't go any further. And this is when you would traditionally use the quadratic formula. I can't do the square root of 13. So I'm done, I'm stuck. I can't go any further than this. I want to show you one that's a little bit weird right now. Try the next one.
13 though, I got
1 squared minus 4 times 1 times 3.
I know, and then when
-3.
I know, so it'd be 12 minus
1.
4.
No. 1 squared is 1.
Yeah,
-4 times 1 times -3 is positive 12.
yeah.
1 plus 12 is 13.
Well, what about the -4?
It's -4 times 1 times
Which gives you
-3.
-4.
Times -3 is?
Oh, because I'm distributing the -4.
Oh,
to
yeah, you're
both.
doubling it. Yeah, no doubling. Okay, try this next one. You're gonna get something very weird looking.
What are we doing before?
Oh, no. It's an imaginary number.
Yes, it is.
What? I didn't even do it. All I wrote was x equals.
Okay, ready?
All I wrote was that.
X equals, again, I'm doing some stuff in my head right here. 2 plus or minus the square root of -2 in parentheses squared minus 4 times 1 times 5 all
Why
over
isn't it
2
-2?
times 1. It is -2.
No, like, how do
Oh,
you
because you have,
positive
it says -b. So if b is -2 and then I negate -2, it becomes positive 2. So x will equal 2 plus or minus the square root of
What do you do?
-16
Wait,
I think, right? Wait.
Yeah.
Yeah, it's
Yeah,
not bad.
over 2, and I'm just gonna leave it like that, I'm not gonna go any further.
Okay.
Yes.
But would it be 4i?
Yes, it would.
Yes.
Okay. Now, which is striking me as odd, because I don't think that's factorable. 4,
So would it be 2 plus or minus 4i over 2?
yeah, I'll just leave it like that for now, I'm not comfortable with it, but I don't wanna lose time. All right, if I did the quadratic formula to this, I would get the following. And if I did it to the middle one, I would get. Okay. Well,
I got 18.
uh,
Oh wait, just kidding.
9, yeah, this should be 49, that's right. Okay? Now, what I want you to notice is a couple of things here, okay? What's the square root of 49? 7. So if you can find the square root, if you can figure out the square root, then you get roots that are rational numbers, okay? And you're also going to get unequal roots. Because can you see how one of them is going to be plus 7 and one of them is going to be minus 7? And that's going to lead you to 2 unequal answers? Hold on, let me go through this. Is everybody with me on that? Okay. Now, let's take a look at the next one. The next one works out, if you did it under the radical, to be the square root of 0. To be the square root of 0. What is the square root of 0? 0. One of them will be plus 0, one of them will be minus 0. Isn't that the same exact thing? So these roots will be rational. However, instead of unequal, they will be equal. Now, let's take a look at the one in red. The square root of 13, is that a rational number?
No.
No, it's irrational. So the roots will be irrational. Now, do you notice how through all of these examples, I don't even care about these numbers in front and in the denominator? All I care about is what's going on with the radical. Let's take a look over here. I come out with the square root of negative 16. This is actually works out to be imaginary.
How is it imaginary?
Imaginary is whenever you get a square root of a negative. That's the definition of imaginary.
Imagination.
There you go. All right, so, listen. Hey, guys, do you see this thing here? Oh. This is the discriminant. Stop hacking up and start listening. This is what we call the discriminant. Now, discrimination can be a very bad thing. If you look at someone's skin color or their religion and you discriminate on them because of it, that's a problem. But it can also be a really good thing. For instance, if you have a drug addict and that drug addict wants to date your brother or sister, you should discriminate against the drug addict because there's going to be a bit of a problem. And drug addict's a little strong. Let me not say drug addict. Let me say drug dealer and MS-13, okay?
Oh my God.
Yes, we should discriminate against that, not based on something that you inherit like skin color, but based on your choice of profession. Now, we discriminate here based on the radical. Hey, if the radical is a perfect root, you should. You want your little sister dating some drug dealer MS-13 member?
No, they're both like laughing like what's going on?
Now, listen, you're discriminating.
Chill.
Don't move. You're discriminating based on the radical. If the radical is a perfect root, like 49 or 100 or 9, it's going to give you, hey, enough. It's going to give you rational number answers. If it is 0, you're going to get equal answers. If it's a number like the square root of 13, I can't reduce that. That's irrational. And if it's a negative, then it comes out to be imaginary. Okay? Hasta la vista. Yeah, I got a class full of kids who want little brothers and sisters dating MS-13 drug dealers. That's right. All right, Kaylee's all set?
Yeah.
Good.
Brian, so run the pacer,
I
my
love the paper. Wait, so if it's rational, like what?
It's a square root you can't figure out.
So
So anything
it's
that's
irrational?
if anything we call a perfect root is rational, like 25, 9, 16. But if you can't do it, like 17, that's irrational.
Like the square root of 76.
Irrational.
But would it be unequal?
Yes, because one of them's going to be plus that number, one will be minus.
Could you ever factor completely the quadratic formula when we plug it in? Can we ever?
If at the end of the quadratic formula you come out with a perfect root under the radical, you could have factored.
What time
If
is
it doesn't
the
come out,
library
you can't.
Okay.
All right. You're welcome. What was that, Lipstick?
What time is the library tonight?
The library is 5:30 to 7:30.
I'm like after 6 because I don't violate.
Well, I also, in all honesty,